Welcome everyone. Let's learn how to differentiate trigonometric functions. Fx is given to us as sine x, and the question asks us what is derivative of fx. Clearly, we need to differentiate sine x. I'm gonna give the answer immediately. F derivative x is equal to cosine x. If you differentiate sine x, the function you get is cosine x. You can learn this like this, but I recommend showing this with the the derivative definition we have for once, because if you show it even for once, you will have control over your knowledge, which is really important in mathematics. Understanding why is really important for us. It is more important than memorizing things. Let's try to evaluate this derivative. Let's differentiate this with the limit. Limit h approaches 0, our fx is sine x, so sine x plus h minus sine x over h. I can't do much here. I need to remember the property of trigonometric function sine x plus h. I can write this part as sine x times cosine h plus sine h times cosine x and minus sine x. You can do this for sine a plus b over h. We need to group this now. How can we group this? With sine x and the cosine x. Under the sine x parentheses, I have 1 cosine h and a minus 1 from here. A minus 1 from here. This is over h. Plus cosine x. I only have sine h, right? So sine h over h. I had two special limits. There are a lot of methods to prove these limits, but we will not do those proofs in this video. You can check it out. This special limit is equal to 0. We learned this in our special trigonometric limits video. Sine h over h, and this limit is equal to 1. By these two special limits, this part is 0. So clearly this part is gone, which is equal to 0. This is 1, and cosine x times 1 is cosine x. Don't forget the variable is h, so I don't plug the 0 in for x. With this, I showed that derivative of sine x is equal to cosine x. Let's speed up the things a little bit. Let's say our fx is cosine x. I'm not going to do the limit of this because it's exactly the same. F derivative x will be equal to negative sine x. If you try to show this with limit, you will see you're getting exactly the same two special limits. By these two limits, you can evaluate the derivative. Let's continue. Let fx be tangent x this time. I want to differentiate this function. What is f derivative x? First, I need to know that tangent x can be written as sine x over cosine x. By differentiating division of two functions, let's show that we are differentiating this. The derivative of denominator and numerator, cosine x times cosine x, minus derivative of numerator, which is cosine x. Differentiate this, negative sine x, so this will be a plus, sine x times numerator sine x. This is over cosine x squared. This is equal to cosine squared x plus sine squared x over cosine squared x. From here, you can get two equations. First equation is If I separate this into two fractions, I get 1 plus tangent square x, because cosine squared x over cosine squared x, which is 1, sine squared x over cosine squared x, tangent x squared. The other trigonometric function you can get is my numerator is equal to 1. Cosine squared x plus sine squared x is equal to 1. This is over cosine squared x, and as we know, 1 over cosine x is equal to secant of x. So this is equal to secant square x. Last function, cotangent of x. Let's differentiate this function. Again, we need to write it in a different form. Cosine x over sine x. Let's differentiate by division again. Negative sine x, I don't want to put parentheses here. Negative sine x multiplied with sine x minus cosine x times cosine x over sine squared x, which is negative sine squared x minus cosine squared x over sine squared x. I can write this as under the minus parentheses, sine squared x plus cosine squared x over sine squared x. Why this step is important? Because now I can write this in two different fractions again. What does this give me under the negative parentheses? 1 plus cotangent squared x, right? Because cosine squared x over sine squared x here. I have one more trigonometric function here. This is 1, right? Because sine squared plus cosine squared x. Again, negative 1 over sine squared x, which is equal to negative cosecant squared x. With this, we learned derivative of 4 different trigonometric functions. If you want to summarize them, cosine x, derivative of cosine x, sine, negative sine x, derivative of sine x, cosine x, derivative of cotangent x, negative 1 plus cotangent squared x, derivative of tangent x, 1 plus tangent squared x. These are equal to cosecant square x, secant square x.